you've done stuff like this, where you had the sine of some theta was 3/5. You press some buttons in the calculator to figure out what the angle is. Well, guess what? You're not using a calculator. Which means you have to know how to set them up and solve them. Which means there's only going to be so many different angles that you can choose from. Gee, I wonder what angles we're going to be working with. And quadrantals, exactly. So what happens here is we're going to be asking the question, what angle has? What angle has? It's basically the same idea. You guys have done this before, where you've written it out as sine -1 or cosine -1, tangent -1, and you press buttons to figure out what angle has. What this stood for was what angle has the sine of some crummy decimal. Okay? What angle has the tangent of some crummy decimal, and so on and so on. So what we do, though, is we take it in terms of the trig functions, and which means we have to sit there and make sure we plot things correctly. We still spin around to figure out what angles or where they have to go. But the idea here is we have to know where to start. And when we're searching for angles with sines, cosines, tangents, and other reciprocal functions, there's certain parameters that you search through. Okay? And that's where things get a little muddy up front. After which, after you get going with a couple of them, you're like, oh, well, that's pretty easy, as you continue on, okay? So what happens here is we're going to work with sine values. When we're searching for sine values, there's a couple, like I said, there's a couple of rules. There's a couple of rules. Sine values are anywhere between 1 and -1. We know that because it can't be larger than 1, it can't be smaller than -1, otherwise it would be busted out of the circle. Remember how the radius is 1 and out around. So what happens is when we're looking for sine values, we wind up looking for them between pi/2 through -pi/2. Okay. The reason why we drop down to the fourth quadrant as opposed to going to the second quadrant is because what happens to the sine values in the second quadrant? They're still positive. That's the thing. Positive values are still in the second quadrant, so you have to figure out another quadrant where the values themselves change their signs, S-I-G-N. Okay? That's why they drop from first quadrant to fourth quadrant, because they still share the same reference angles and stuff, but then they get the different sign values as far as positive and negative. Okay? What happens with cosine then is, so first things first, sine, positive and negative pi/2. Okay? Cosine goes positive and negative between 0 and pi. We search the cosine between 0 and pi because cosine starts positive in the first quadrant. As it gets to become second quadrant, it goes negative. That's why we search through those. As you go around, that just means basically you're just going to be plotting our triangles. If you had to find a cosine, what angle has a cosine? If it's negative, your triangle you draw is going to go to second quadrant. If it's positive, your triangle you draw goes to the first quadrant. If sine values, if the sine value was positive, you draw it first quadrant. If it was negative, you draw it to the fourth quadrant. And you fill in the blanks accordingly. Okay? This sounds overly complicated, but when you see a couple examples of how it goes, you're like, oh, this is okay. So cosine goes first, second, and then the last one is tangent. Tangent has also follows the same pattern as sine, but it does not include pi/2 and -pi/2. Reason being is when you think about your quadrantals, when you're up at the top here or down at the bottom, your ordered pairs were 0 +1 and 0 -1. That meant that the tangent value would have been 1/0, which was undefined. Same thing with the denominator, you'd have -1/0, so they're undefined. So that's why we leave them as open dots there, because they're not inclusive of those. And remember, what was it, 2 days ago when I started doing some of the graphs? I forget. Is that yesterday we graphed that?
Yeah.
It seems like forever ago. So yeah, so when you graphed things through, we knew that tangent values were not continuous. Tangent values had asymptotes, which stopped itself as it went through certain values. It approached them and it came through and they ducked and died. No, excuse me. So, tangent ones again, we're going to go first quadrant to fourth quadrant. It's just the easiest way to see how those values themselves work themselves out. They don't go for, some people always ask, why don't they go first, second? They can't go first, second because they get stopped at pi/2. Does that make sense? Because it would make sense because tangent's negative in the second quadrant, but you can't get there because you can't get past the asymptote. That's why it goes up and down. So here's what they're going to look like. They're going to look like something like this. Oh, we had those. Sorry. Question will be like this. Sine to the negative 1, which means what angle has sine value of root 3 over 2. Okay. So what quadrant does this have to get drawn into? First quadrant. Okay. The reason that it's going to be first quadrant is because this value is positive. So real fast, all we have to do is this. I draw a little triangle. I know my reference angle has got to be here. Sine is what over what?
Opposite over hypotenuse.
So what's your opposite? Root 3. And then there's 2. What angle has the opposite of the root 3? 60. So what angle has the sine of root 3 over 2? Pi over 3. Try and keep everything in radians. What angle, think of it this way, is you're always asking what angle has sine value of root 3 over 2. Okay. You okay, Feeny? Okay. Okay. You're okay plotting it, right? Okay. Is that a 30, 60, 90 triangle or 45, 45, 90? Okay. What angle has a root 3 opposite it? The 60. Always go to radians though. So it's pi over 3. All right. What angle has a cosine of 2? I don't know. Tell me. Yeah. If it's a quadrantal, what are your order pairs of the quadrantal?
0 and 1.
I don't see a 2 there, do you? Can cosine be larger than 1?
No.
Can cosine be smaller than 1? Or smaller than negative 1? No. Is this possible? No.
That was a trick question.
Can't do it. It's not possible. Cosine values are stuck between, just like sine values. Cosine and sine are bounded between 0 or negative 1 and positive 1. So this is impossible. Yeah, this is impossible. Okay. I got that out of order. What angle has a tangent of negative? What angle has a tangent of negative 1? Okay. Now remember, if it's tangent, that means I'm looking first, fourth. If it's negative, which means I'm in fourth. Okay. Again, we draw. It's got to be down here somewhere. I don't know which triangle I'm at, but I know my theta value. I know it's going to be a negative because it's in the fourth quadrant. Okay. Now, tangent's what over what? Opposite over adjacent. In order for it to be negative 1, that means it has to be what? What triangle? It's got to be 45s, right? Because this got to be a 45 here, because this would be a negative 1, this would be a positive 1, there's your root 2. So that's reference angle of 45, but I'm in the fourth quadrant, so what would it be? Negative pi over 4. Okay. Now, remember, I'm not spinning around in this case. This case, I'm looking for values between pi over 2 and negative pi over 2. Non-inclusive. Yeah, dude. What's that? Tangent can be. Tangent can be. It's not because it's not on a quadrantal. Okay, you're not on a quadrantal in this case because when you're looking at opposite and adjacents, tangent's y over x. For tangent to be 1 or negative 1, the y and x value have to be the same. So that's how that one works itself out. Okay. Yes, ma'am. What triangle has opposites and adjacents added at the same? So, because remember, because tangent, in order for it to be a 1 or a negative 1, the fraction has to be the same top and bottom. That's how it works. Okay. All right, take a minute, try those. There's only so many of these that we can do, honestly, because there's only 2 triangles as you get into them. So let's see, we have what angle has a tangent of root 3, what angle has a cosine of root 2 over 2, what angle has a sine of 1/2, and what angle has a cosine of negative 1/2. Remember, always draw, bless you, always draw them first to figure out where you're at, and then start going back against your triangles. Remember, the 2 triangles you're always using, it's either a 45-45-90 or a 30-60-90. What's up?
I got it.
So for number 5,
Yeah.
how do you know which one? Never mind, I'm stupid.
Stop saying that.
Well, never mind, I figured it out.
Great question. Always think about how you're setting it up. Tangents what over what? Opposite over adjacent. There's no adjacent value there. What's technically there you don't see?
But I think I know which one, how you know which one is opposite, and then that I thought of the other one.
If it was root 3 over 3, then it would be something different. For tangent to work, it's positive. Had to go first quadrant. I'm assuming most of you guys have gotten this far. What angle has opposite the root 3 and the adjacent, the 1, the 60. So there's your 60. So your answer here would be pi over 3. Okay. We do a lot of back and forth. When you go into your triangles, you're going to use 30s, 60s, and 45s because it's what you're used to. Solution-wise, you go back to radians. Okay. Root 2 over 2. Well, with root 2 over 2, it's positive. Again, your first quadrant. To get a root 2 over 2, that meant it had to have been rationalized. So if you think about it, what would be the unrationalized version of that? 1 over root 2. Okay? So you do a lot of backtracking. Whenever you see rationalized things like this, root 2 over 2, or you see root 3 over 3, you know it's been flipped around. So you've got 1, 1, and your root 2, which means that had to have been a 45. Which meant your answer is pi over 4. Good. All right. Inverse sine. What angle has a sine of 1/2? Again, sine is opposite over hypotenuse. It's first quadrant because it's positive. So your opposite is 1, your hypotenuse is 2, which means the root 3 is your adjacent. What angle is that? 30. Your answer is pi over 6. Good. Okay. And then the last one with the negative, that meant when I draw it for cosine, I have to go to second quadrant. For what? For which one? Oh, did I write pi over 2? I'm sorry. That was what? Pi over, yes, pi over 6. I'm sorry. I was looking at the 2 probably when I was writing it down.
You said pi over 6.
Yeah, you said it.
Huh. I was probably looking at the next value of 2 as I was writing it because I'm just getting ahead of myself on that one. Yes, ma'am. For 8, actually it's second quadrant. None of them go to the third. None of them go to the third. So cosine, it's negative. So it's over here. So here's your -1. Here's your 2. That has to be your √3. Okay. Now that means you have a reference angle coming up. This is the tricky one now. This is the tricky one. What angle has the cosine of -1/2? So that had to have been a reference angle of, what is that, the 60? So it's pi over 3 up, which means their angle to the terminal side would be 2 pi over 3. Very good. Because you got to come to here. This is your 2 pi over 3. Because the angle, in order for it to wind up being negative, it has to lie within that second quadrant. You just utilize the reference angle to get there. Cosine's the trick one. If you do a cosine value, what angle has a cosine of negative? Your angle that creates that has to be obtuse. Has to be greater than pi over 2. Okay? That's the trick on that one. All right? These shouldn't be that bad, in all honesty. Okay? Yeah. Let's see what I have up here. Cosine of -1. Okay, cosine of -1. So this is asking you what angle has a cosine of -1. Well, to get a cosine that's just -1, that means it had to be on a quadrantal. Where is x -1? Over here. Because that's -1 and 0, so this is at 180, otherwise known as pi. Again, it has to make sense that it's got to go over to the second quadrant for it to be negative. Even though it's a quadrantal, but you get the idea. That's how these things work. The downfall of this section is that the textbook only has like 10 problems of it. Okay. But in all honesty, there's really only like a dozen or so you can do. Because if you think about it, in each quadrant there's 3 angles. So you've got 3 in the fourth quadrant, you got 3 here, so for sine, and then you take into consideration the quadrantal, so you've got 9 possible sine angles you can find. There's only 7 possible tangent angles you can find, and then there's 9 possible cosine angles. So there's not many there, because you're not getting repetition revolution ones, because it just throws you within that specific parameters. So inverse functions are really easy, because there's only, 9 plus 9 is 18, 18 and 7, there's only 25 different angles that you can do. That's kind of, it's the same thing over and over again. Okay. Here, I wanted you guys to just do those that are in the text. I believe the PDF is up, but I also made another sheet that mirrors what we did yesterday about finding angles. So I wanted to give you guys that one for an extra practice as well. It's got them in both radians and in degrees, so it's just evaluating the expressions, just like we did that chunk in the textbook yesterday. One side's got I think I mixed them together with radians and degrees. Yeah, this one just, these are a lot like those that group of 12 problems we did in class yesterday. These match out. Hey guys, hold up. The sheet I gave you matches those 16 you did yesterday. It's just extra practice ones of them. So it would not be a terrible, terrible idea to try those out. Also, let's see, which one was it? Oh, I didn't put it on here. All right, never mind. I'll talk about the fancy one I made up tomorrow. Go through these things also. That way you keep practicing about spinning it to find the reference angle and you can evaluate. And then do the other ones that were, I don't know if you guys wrote it down yet. The 13-4. I'm still thinking we'll be okay for Thursday. I don't see this being a big deal. Tomorrow, I'm moving the Trigorama quiz thingy to Thursday because there's really no reason for us to stall on it. I mean, I really don't see another day. I'd rather have the extra day for trig identities than anything. Those can get kind of messy. Hey, guess what? Proofs come back.
No, he's only good.
Yeah. Because the reference angle is and it has to be obtuse, so it's got to be. No big deal. What do you want?
A question.
What do you got?
So, if it's ever just like negative one or if it's ever negative one, that means it's always going to be
For tangents? Yes. For tangents, yes.
So, okay. So is that means it's always going to be higher than one?
Yes. If it's 1 or -1, it's going to be either prior or negative.
Oh. And that just depends if the one's negative or not?
And the nice thing about tangents is there's only so much you can do. Is it not up there yet? Okay. I thought I did. I wasn't sure if I did or not. As I moved a bunch of dates around, I might have accidentally created the wrong day.